Dear students, today we'll start with name reactions. To start with, number one, we'll do with Finkelstein reaction. In this reaction, alkyl iodide is often prepared by the reaction of alkyl chlorides or bromides with NaI, sodium iodide, in the presence of dry acetone. Okay, you can see here Rx, R is your alkyl group, X is your halogen. Okay, halogen you have two options, either it's a chloride or bromide. So when this alkyl halides is reacted with sodium iodide, it forms alkyl iodide as a major product, and will have a side product as NaX, or NaBr or NaCl. In the presence of dry acetone, we need dry acetone. Okay, for example, if we take a particular example, we can take this ethyl chloride, okay, plus sodium iodide in the presence of dry acetone. So it will form CH3CH2I plus NaCl. Okay, so this is basically the halogen exchange reaction, so in which the chloride is replaced by iodine. So chlorides come out from here, iodine will go inside. So here we need a reaction medium as a dry acetone. Dry acetone means, okay, it's a acetone without any water. Okay, there should not be any moisture or water vapor, etc. So it should be dry. Another example we can take is a CS3, suppose Br. Okay, example number 1, example number 2. So when it reacts with sodium iodide, always remember we need a dry acetone. Then the bromine will come out, iodine will come in. So CH3I plus NaBr. So whenever we need a iodine in the product, we need a alkyl iodide as a product, then we have to do this reaction, halogen exchange. So you have to remember we need the reactant as a reagent as a sodium iodide. Number 2 is Swarts reaction, in which we normally prepare alkyl fluoride from alkyl chloride or bromide. So the general reaction is Rx plus AgF is one of the reactant, any metal fluoride, okay, you can take. So it will form RF, alkyl fluoride, plus AgX. We can take a particular example, like if we have a CH3 CH2Cl, then when we add AgF, there is a list of reagent. Okay, we'll write that later on. So our product will be CH3CH2F plus AgBr. Okay, now instead of AgF, we will have a set of reagents. So that could be, we can use Hg2F2 or COF2 or SbF3. You can use any of this reagent to convert this alkyl halide into alkyl fluoride. Here remember, X must be either chloride or bromide. Okay, so this chloride will be replaced by fluoride. Another example you can take, suppose CS3, if we have a Cl, then when we add this COF2, remember this is cobalt, okay, and some heat is also required in this process. So your product will be CH3F plus COCl2. Okay, so we need to balance the reaction, right? So this is your Swarts reactions. So remember, in Finkelstein reaction we prepared alkyl iodide, in Swarts reaction we prepared alkyl fluoride. Next important reaction is Sandmeyer reaction. So in this reaction, when aniline is treated with sodium nitrite, okay, NaNO2, NaNO2 is nitrite, plus mineral acid, so it could be HCl or HBr. The temperature is here 0 degree to 5 degree centigrade, okay. Now your diazoxide salt will be formed, benzene diazoxide salt will be formed. It will be, we'll just write N2 plus Cl minus, okay. This is benzene diazoxide salt. When this is treated with cuprous halide Cu2X2, okay, it could be copper chloride or copper bromide, cuprous chloride or cuprous bromide. Cuprous means oxidation state is +1 here, copper. So then benzene halide is formed, X, okay, this will come, plus some side product will be released. Now this X has to be your chloride or bromide. Remember, X has to be either Cl or Br. This is your Sandmeyer reaction. To take a particular example, if we have to prepare suppose chlorobenzene, if we have to prepare chlorobenzene from aniline, so this is your aniline, aniline, then we have to add NaNO2 plus HCl, okay, 0 to 5 degrees Celsius. In other words, you can also write as a 273 to 278 Kelvin, okay. So it will form a benzene diazoxide salt. So it is N2 plus Cl minus, and you have to add cuprous chloride, okay. It is written as a Cu2X2 also. Sometimes it is also written as a CuX whole 2 also. So we'll add CuCl, okay. We'll just write 2 then what will happen is a chlorobenzene is formed, Cl plus some side product. The very important thing is that this is NaNO2 sodium nitrite, not the nitrate, it is nitrite. Nitrate is NO3, nitrite is NO2. So sodium nitrite plus HCl, okay. You have to mix this and you have to dip the solution in a ice bath, okay. We normally have one ice bath, okay, a container containing some ice cubes. So we'll dip that test tubes here, okay, and we'll maintain the temperature 0 to 5 degree. Then after that, this solution aniline is also kept in another test tube in this water bath. Then we'll mix the two solution, okay. We'll mix these two solution, then your benzene diazoxide salt is formed, okay. Then when you add cuprous chloride, then your chlorobenzene is formed. Sometimes you must know that when these two reacts, like NaNO2 plus HCl, first you have to mix these two, okay. So it releases your HNO2 plus NaCl, okay. In the some reactions, instead of NaNO2 plus HCl, it is also written as a HNO2, okay. You have to understand it is the same thing. Suppose in some reaction, if it's given like this, and H2, and it is written here HNO2 0 to 5 degree Celsius, okay, then remember it will form your benzene diazoxide salt, N2Cl, N2 plus Cl minus, remember, okay. Because how HNO2 comes? Because HNO2 comes from this reaction, NaNO2 plus HCl, so it gives HNO2, okay. Instead of HNO2, sometimes it is also written as a HONO also, okay. In some books it is also written like this. It's the same thing, okay. So when you treated with, suppose instead of CuCl2, it's also written as a CuCl Cl whole twice. Okay, sometimes it's also written as like this. So your product will be the same thing, chlorobenzene, plus some side product will be there. So this is your Sandmeyer reaction.